Hello and welcome. You're watching the session Secure Delivery in Our Remote Reality, Modzy's Approach to DevSecOps. First, wanted to introduce myself and tell you a little bit about my background. So my name is Nathan Mellis, and I am the head of engineering for Modzy, a new enterprise artificial intelligence platform and marketplace that came out of stealth last year at NVIDIA's GTC conference. Prior to joining Modzy, I've worked for Booz Allen Hamilton and Apple, doing everything from software development to cloud architecture, user experience, prototyping, engineering management, and the list goes on. If you have questions or want to reach out, you can find me on LinkedIn or Twitter. Information here on the slide. So today, what are we going to cover? So we're going to talk about lessons learned on Modzy's journey towards establishing a DevSecOps practice. Hopefully some of this information will be valuable to you as you think about your own DevSecOps practices. First off, we're going to talk briefly about why one might bother with DevSecOps at all, and understand the reasons why investing in this process can bring value to your engineering organization. Next, we're going to cover some basics of information security so that we have a foundation for discussing how those principles guide us in establishing the security portion of DevSecOps. After that, we're going to cover a few best practices that we've discovered along the way and where we want to draw inspiration as and where we drew inspiration as we were designing our own process. Finally, we'll walk through some practical examples and how applying some of these principles might work out for delivering a Kubernetes-based product and show how those principles can be applied using some practical examples. So let's dive in. To start, what is DevSecOps and why are we talking about it? If you're at this conference, you probably already have a good handle on DevOps in general, but let's quickly review some of the basics. DevOps, simply put, is the discipline of creating a process by which code moves quickly from a developer's environment to a production environment while ensuring the desired amount of quality. Humans, as it turns out, are really bad at doing the same thing exactly the same way over and over again. So it's quite common that DevOps processes are heavily automated because, as it turns out, computers are quite good at doing the same thing over and over again the same way every time. So DevSecOps then is the discipline of weaving security best practices into the DevOps process so that security is applied at each step along that process, making security an integral part of your software development process rather than something that's bolted on at the end. But why do we need a process at all? In the good old days, building and preparing software for shipping involved something like this. SVN checkout against some server, CD into that folder, /configure, make and make install. Or if you were a web developer, it was even easier. You just copy the files onto your web server and you tell Apache to gracefully restart itself. For better or worse, our reality is far different, and these approaches are no longer sufficient for delivering most software, especially things that are cloud native, container-based, Kubernetes, etc. Over time, as the complexity of software has grown, we've gone from bash scripts to Perl scripts, infrastructure automation like Puppet and Chef, to virtual machines, containers, container orchestrators, infrastructure as code, and it keeps going. Next year at this conference, I'm sure there's going to be some fun new thing that we're going to be talking about that's going to be all the rage. To further reinforce this point, one really only has to look at JavaScript. Chances are your web application, if it's been written within the last few years, was written in something that is like JavaScript, for example, TypeScript, which is a great language, by the way, but it's not actually JavaScript, and typically requires not one, but at least two different transpilation steps before it can be delivered in a form that can be consumed by a browser. The point is that modern applications have many more layers than before, and all of that needs to be coordinated before the application can be shipped. Similarly, the adoption of microservices has given rise to a whole new suite of coordination tools like Eureka, Zookeeper, Consul, Kubernetes, and some microservice-based applications even go so far as to require things like sidecar proxies such as Envoy in order for the microservices to be able to communicate with each other. So to achieve a rapid quality delivery with all these extra layers and coordination, a mechanism is needed to ensure that the correct process is always followed in a consistent and deterministic manner. That's why we need DevOps. And if you're in the cloud and have your infrastructure as code, then it's probably occurred to you to evaluate what IAM roles, users, policies are created in that automation, and what security groups and network policies are needed by your infrastructure code. But if you're running with something like Kubernetes on one of the major cloud providers, then any developer who can create a load balancer service will cause not only new infrastructure to be automatically provisioned, but new security groups to be created as well that may or may not conform to your organization's policies. That's why it's so important to consider security in your delivery process as well. As more and more of your application stack moves to the left and becomes code, you need to move your security practices to the left as well. So let's take a minute and quickly cover the basics of information security. And in most cases, they are as follows. You have confidentiality, integrity, and availability. Confidentiality is the principle that governs who has access to what information or systems. Which information or systems should be confidential is, of course, up to you and your organization, and should represent one of the first key decisions that you'll need to make when standing up your DevSecOps processes, and we'll talk more about this later. Integrity is the principle that requires that the data about your information and systems is accurate and reliable. The decisions you make here will drive what kinds of auditing and security alerting you'll need to set up as part of your DevSecOps processes. Also, with regards to DevSecOps, this also goes into having you determine what the provenance of your artifacts are, ensuring that you are shipping only and exactly what you're expecting to ship. Availability is the principle that ensures that people have timely access to your information and systems. The decisions you make here will determine what policies and monitoring you put in place typically. Now let's talk about how we at Modzy took these basic security principles and applied them to our own design thinking. So first, with regards to confidentiality, we asked ourselves what parts of our software delivery process might need to be confidential. Our key takeaway when considering this was simply know what needs protection. This may sound rather obvious, but it's important to devote some significant thought to this question early and often. We wanted not only to consider the obvious things like protecting our secrets, but also the downstream effects of secrets, like protect the things that have access to secrets. Obviously, at some level, our continuous integration and continuous delivery tools would inevitably have various levels of access to our environments, and certain repositories in our source control would have access to information about our environments as well. So we would need to afford those tools the same level of protection that we would to the environments themselves. Otherwise, our tools could become a vector for human error or malicious intent. We'll talk more about this when we design our notional process and share some of the ways that we approach securing our tools that had access to secrets. But it was also important that we considered what were our most valuable or our most risky assets. These could be things like intellectual property, things related to patents or certain proprietary information, or could also be things that were related to things that were export controlled. Modzy is an artificial intelligence platform and marketplace. And even though artificial intelligence largely is not export controlled at the moment, it's something that's being actively discussed, and we wanted to make sure that we were ahead of that particular game. You might also consider internal security code for your product. If your product does license management or internal security, or if you've got your own encryption schemes or things like that, those may be aspects of your process that you may want to add some additional layers of security around to make sure that your junior developers just out of college that aren't working on security don't have the ability to poke around and see things that they really shouldn't see. And finally, you also want to consider your environment configurations. Oftentimes, environment configurations can contain information, about your environments, where your databases are located, what those credentials are, maybe what policies are applied, and those are things that you might want to consider confidential and not have broad access to within your engineering organization. Since Modzy was born as a remote native company, we needed to consider not only what to protect, but who and where to protect it from. I'm guessing that many of you who have transitioned to majority remote work at first didn't have all of the VPNs and network and content monitoring, centralized endpoint protection for all your remote workers to match the same kind of a setup that you may have had in your corporate office. But even when you do have those protections in place, your teams are still working on untrusted or potentially even hostile networks like coffee shops, as well as on unmanaged personal computers and mobile devices. Care and consideration should be taken to ensure that a compromised home computer or network does not put your confidential information or assets at risk. This is the where that you want to protect from. It's also to consider who you want to protect from. When all your developers are remote anyway, it can become possible to pull talent from a larger pool than traditional recruiting. A lot of talent can be found through gig economy workers, offshore and nearshore contractors, and more. Consider what aspects of your information and tools might require different levels of access. Things like source control, build systems, artifact repositories, wikis, document libraries, just to name a few. So this is a whole topic in and of itself, and far more than we can get into today. Suffice it to say that there are decisions that you should make when designing your DevSecOps process that can help mitigate some of these risks, which we'll cover a bit more later. Next, let's talk about integrity. And this is the things you might want to consider, or parts of your process that might require additional checks to ensure the provenance or the accuracy or the reliability of that information or artifact. So to recap, integrity is the principle that requires that the data about your information or systems is accurate and reliable. Again, we began with the obvious with regards to a DevSecOps process. Know what's being shipped. We of course want to be able to trace everything back to a particular commit in our source control, as well as have references to all of the test results for every unit test, integration test, security or penetration test that was performed along the way, so that we had the maximum amount of assurance that we could get that we were shipping exactly and only what we intended to ship. This also meant that we needed to know what tests to perform at each stage of the delivery process. We'll cover what kinds of tests to consider running later on as you're thinking about your own process, and you'll need to decide what tests are appropriate for your product. We also thought it was important to ensure that we could verify those test results before moving on to each delivery stage. Obviously, just testing is not enough. We needed to define success and failure criteria for each test and not permit artifacts to proceed further along the promotion process into higher environments if a test failed our defined threshold. It was also important to us to ensure that our artifacts could not be modified or replaced after those verification checks took place. It doesn't do any good to verify that your artifacts are free of vulnerabilities or bugs if they could be replaced midstream by something that hasn't undergone full testing and validation. Ultimately, it was about establishing a provenance for each of our artifacts by the time they reached production. We wanted to have a full, verifiable history of each artifact and the confidence that nothing out of our process occurred along the way. Next is availability. To recap, availability is a larger conversation than we can cover in this talk. So I'll simply say that when it comes to designing a DevSecOps process, our key takeaway here was to monitor everything considered important. We're going to be relying on a lot of automation to achieve most of our goals, and automation is only effective when it's all running normally. So we need to make sure that every critical piece to our process is monitored for proper functioning, and that we would get the appropriate alerts if any anomalies were detected. Now that we've covered the basics of security and how those can, be thought of in a DevSecOps context, let's distill some of those lessons into some best practices. But before we do that, I'd like to add one additional best practice that we here at Modzy think is crucial to maintaining a healthy development team. And that is the developers should be empowered to be as self-sufficient as possible. We love our developers, and despite all the process and security constraints that we're talking about adding, we want to make sure that they're done in a way that doesn't adversely affect our development team's ability to move fast, experiment and test new ideas, and ultimately develop features quickly. We're a startup moving at startup pace, and to achieve that pace, we need to be careful about what kinds of roadblocks we put in their way. And so we think it's really important to empower our developers as much as possible. So now going on to some best practices. First up, one of the things that we think should be considered a best practice, taking into account all of the security practices that we talked about before, is that non-production environments should be considered ephemeral. Practice makes perfect, or more accurately, perfect practice makes perfect. And by regularly repaving our non-production environments, we gain a few things. First, we practice deploying and configuring our entire stack from scratch on a regular basis, quickly identifying areas that we have yet to incorporate sufficient automation. Second, we clear out any cruft that's no longer relevant to ensure that we aren't ignorantly relying on something that may have been done in the past, potentially without any documentation. There's nothing more frustrating than promoting code to a new environment only to find out it doesn't work because something about that environment was slightly different than the environment it came from, with no discernible reason why. Ultimately, the goal is to ensure that the integrity of our application is proven to ourselves on a regular basis, and that we know exactly what we're deploying. And we do this by wiping everything out and redeploying from scratch regularly with what we believe is necessary to run our product. Next, nothing should be promoted or deployed except by automation. Similarly to the previous best practice, this helps us ensure that the integrity of our product is maintained, because each promotion or development is done in a way that can be audited and doesn't rely on a human being following a checklist perfectly every time. It also helps us preserve confidentiality of our environments, because humans no longer need privileged access to those environments to do the deployments. If you're doing your development in the cloud, confidentiality can be further preserved by using different cloud environments for dev, test, and prod, further limiting the access that certain humans need to have to those environments. For us, this gave us the freedom to grant more access to our developers in our development environment, and we could do this because we can regularly repave it, and so we're less concerned with that cruft that could accumulate, or things that might be done by by developers who don't necessarily know what they're doing in all cases, but then also give no access at all to our test and prod environments, of course, outside of our DevOps staff and automation tools. Next, this hopefully is obvious, practice defense in depth. As we discussed earlier, considering security implications at the end is a necessary but not sufficient step in achieving actual security. Consider the implications along each step of the process and how adverse events during each step could compromise security later on. Finally, educate yourself and find inspiration. When we were considering our own process, we were influenced by a number of sources. First, we drew from our own experiences, things that went well or poorly in the past. Next, we asked both present and former colleagues about their experiences and drew from the wisdom gained there. We also surveyed blog articles, conference talks, and other writings or presentations on the topic to try and benefit from others' experiences. Personally, I always enjoy listening to talks from engineers at, places like Netflix or Google or Amazon, or others that have had to solve problems at a complexity or scale that I have not yet had the pleasure of experiencing myself. The hard-earned wisdom that is shared by those engineers can be invaluable, letting you learn from difficult challenges without having to experience that same challenge yourself. We also drew inspiration from what may be considered an unlikely source. For the past few years, the United States Air Force has been compiling a list of software development best practices and recommendations for implementing a robust DevSecOps practice, and has published a reference design on their website. This is one instance of one of the graphics that they have there. While some aspects of the design are specific to the Defense Department, the recommendations to achieve a secure delivery process are widely applicable and served as a great starting point for us as we considered our own process. If you're interested and want to read more, links will be available at the end of this presentation. Finally today, let's work through a practical example of how to put these principles and best practices that we've discussed to use. This will by no means be a complete example, and of course your requirements may differ significantly from this example scenario. So first off, let's make some assumptions. Let's assume that we're going to be doing cloud-based development in AWS. Let's assume that we're going to be building a Kubernetes-based microservice application. Let's assume also that we are using a self-hosted GitLab or Jenkins for doing source code management and continuous integration. And finally, because this is a Spinnaker conference, let's assume that we're going to be using Spinnaker for delivery. There are many reasons to use Spinnaker for delivery. I'm sure there are, if you're at this conference, you're already well aware of the amazing track record that Spinnaker has for doing complex deployments, multi-region or multi-cloud, blue-green, canary, and all that good stuff. But there are other reasons why you might want to consider using a separate delivery tool from your integration tool rather than have, for example, Jenkins do both. And we'll talk about that when we get to delivery. So next, let's talk about our infrastructure, because ultimately, if we're doing development on infrastructure of some sort. And so to follow our best practice that we established earlier, let's use separate ops, dev, test, and prod accounts. This allows us to set the users who have access to those environments separately so that we can give our DevOps team access to the AWS console, for example, in the ops account, the ability to deploy new tools and services, but none of the developers, so that way they have access to the tools there, but not access to any of the underlying infrastructure. But in your dev account, you may want to give your developers access to that underlying infrastructure for debugging purposes, for experimentation, and the like. But as we discussed earlier, leaving your test and prod accounts largely untouched except by automation has a tremendous amount of value to ensure that everything running in those environments is repeatable. It can be audited, done by automation so that it's done exactly the same way every time, ultimately to establish that provenance and confidence in the artifacts that ultimately make it to production. So as we said earlier, GitLab and Spinnaker will be installed in the ops account. And we're going to use infrastructure as code for the application environment. One of our best practices we talked about before was the ability to consider non-production environments to be ephemeral. And so one way that we can achieve that is to ensure that all of the infrastructure necessary to run our application environment is done by infrastructure as code. So it's something that can be applied over and over again so that we can repave those environments, create new ones on demand, etc. Next, let's talk about asset management. So you have source code, you have artifact repositories, and other things that are assets to be managed as part of your process. So because we might want to allow multiple kinds of developers to contribute to our application, think about separating your repos into different, GitLab or GitHub organizations with different levels of access control based on the confidentiality required for those components. So you may want your infrastructure as code in a different organization from your application code, so that your DevOps team has access to it, but your development team does not. Similarly, if you have security code or things that are proprietary or part of patent applications or things like that, you might want to keep those separate from just your normal like API services or things like that. Your continuous integration server, whatever that is, the access to that should match the repository access. So again, we want to empower our developers as much as possible. And one way to empower developers is to let them figure out whatever's necessary to build their code. And since that's done by your continuous integration server, if they have access to the repository, they should be able to see the results and even edit the process for how their particular application gets built. Artifact repositories. I would humbly suggest that you should configure your artifact repositories to be read only by humans, in order to have the repeatability and help to establish again that integrity of your artifacts. If the only way for artifacts to make it into that repository is through your automation, then you have a deterministic and auditable path for anything that goes in there. And so you want to turn on things like RBAC as well for things like Kubernetes, AWS, and prevent humans from making manual changes as much as possible, especially in your higher environments. And finally, secure Spinnaker to protect environment secrets. This is one of the big advantages of having a separate continuous delivery product from a continuous integration product. Not only does it allow you to take advantage of things like GitOps, but it also allows you to have all of your environment secrets in one place that requires a smaller amount of access than your build tools do. So you might provide read-only access to the status of deployments to your developers, but not allow them to see any of the configuration or secrets for the environments themselves. Those can be managed by your smaller teams of DevOps folks. And so in addition to all of the great things that Spinnaker does in terms of delivery, which there are many, many talks at this conference about, using Spinnaker can also help to improve your security by keeping the thing that has access to your actual environments, having a centralized place that can have a smaller level of access by humans, to control all of the changes in those environments. So now let's talk about the build phase of a DevSecOps process and some of the ways that we might apply some of these principles that we've talked about. First, we could require passing tests before merge requests or pull requests can be integrated with your main branches. Both GitLab and GitHub provide this capability, and it's a great way to ensure that you don't accumulate too much tech debt or things that will need to be fixed later on. Check for certain really important passing tests before you let anything get merged into your mainline branches. So you might consider things like linting for consistency. Consistency is important, especially if you have a large development team that has different people working on code. Unit tests for quality. This one hopefully is pretty obvious, but if you have unit tests, you probably want to make sure that they pass before you consider merging anything. You might want to check open source licenses or dependency trees for any legal ramifications to make sure that you don't include software that might have some additional baggage with it. It's also highly recommended to run static application security tests, looking for things, checking against the OWASP top 10, or checking for SQL injection attacks or embedded secrets, or other things that are sort of known to be bad. Security can start right here with your source code itself. Next, let's talk about the packaging phase. Where at all possible, use hardened CVE-free base images. This can also include things like checks to make sure that they don't run as root, that they don't require elevated container permissions like accessing the host file system, the raw networking stack, can make elevated syscalls, those kinds of things. So start from a known good state wherever possible when you're packaging up your software, especially if you're using containers. Next, again, if you're using containers, or even if you're using an artifact repository in general, use tag immutability. Once a tag is created, you want to make sure that the content in that tag doesn't change, so that you have, again, that established provenance if you ever have to go back and review. And in general, never use latest unless it really makes sense and the particular version, it doesn't matter, or if every new version always supersedes the version before it. But obviously, if you use something like latest, you can't turn on tag immutability. So consider, not using latest and turning on tag immutability to achieve that confidence that the content behind that doesn't get swapped out at some point along the road. Where possible, notarize or digitally sign your artifacts. These are things that can be checked later to ensure that nothing has been changed out unexpectedly on the road from development into production. And this is especially important if you're shipping your product and don't run your own production, but ship it to run in a customer environment. This allows your customers to verify the digital signature to make sure that the artifact that they've downloaded and are running on their own infrastructure is the same one that you shipped. And finally, I would put forward that the packaging phase is where continuous integration should end. We talked briefly earlier about the value of having your continuous integration and your delivery be separate. And among the values of being separate are the security things that we've talked about before, but this also lets you take advantage of practices like GitOps, where you can push your artifact into a repository that could then either trigger some webhook, or you could update, a Git repository with the new tag that was just pushed, which would then trigger off a deployment to follow the GitOps model. But the CI process, can end with the packaging of that artifact, and then hand that off to another process set of tools, responsible people, etc., to handle taking those artifacts and pushing those into the appropriate environments. Next, in the deployment phase, as we just talked about, consider using a different tool or at least a different instance for handling deployment and delivery rather than built-in integration. We've talked about this a bit already, and this is one instance where using a tool like Spinnaker can be really, really useful, something that's dedicated exclusively on doing deployment and delivery really, really well, and then leaves the build and integration steps to tools like Jenkins or GitLab CI, that are more geared towards those task or arbitrary sequence of steps, kinds of processes or pipelines. It's important if you're going to create digital signatures to verify them before you do a deployment. If you are signing them but not checking them, why are you signing them at all? So verify your digital signatures, use GitOps as we talked about, and finally we get to the promotion phase. And it's again important as code or artifacts move from your different environments. If you remember, when we talked about the infrastructure setup, we have different accounts for our dev and test and prod. And so as artifacts move from one account into the other, it's important to verify those digital signatures, maybe verify the test results, and establish that artifact provenance before it's allowed to cross that boundary from one environment into the other. So that way you have a very definable way for artifacts to make it into that environment. It reduces your potential attack surface or area that you need to cover with automation or checks or access control or all of the various tools at your disposal. And then once it makes it into that environment, then you have the confidence that you can then deploy that normally. Again, use GitOps when possible. In addition to allowing for certain levels of automation, it also provides a record of all the changes so that you can verify and go back to know who, what was promoted when, maybe who made that change, and it gives you a full record that can be audited for all the changes in your environment. And finally, consider using different artifact repositories for each instance of your environment. So you could have a shared artifact repository that's used by dev, test, and prod, but again, that doesn't give you that boundary check to move that artifact from one environment to the next. You can't accidentally deploy a development version of an artifact if that artifact never makes it to the repository that your production environment is configured to run against. So consider using different artifact repository instances for each environment. And finally, in the delivery phase, verify again your digital signatures, test results, and artifact provenance. It's important that this is done at every step along the way to ensure that through an accident or negligence or malicious intent, that something can be swapped out along the way. Resulting in you deploying something that you didn't intend to, especially your production environment. Remember, one of our key takeaways when talking about integrity of your application is that you should always know what you are shipping. And so the way that you can do that is to verify all these things along the way. Consider whether you need human approval before delivery. If you are, somebody like Netflix and you're doing thousands of deployments a day, obviously humans don't scale that well. But if you are a shipping product that runs, in a customer environment or on premise or in a different environment from what from where your development takes place in, consider whether you need a human approval, change control board that can, do additional security or documentation reviews before that version is shipped. So in summary, thank you for spending some time with me today. And so key takeaways from this: think ahead. And think about, what you need to know about your process and about your tools and your assets, and then consider those basic security principles. Know what there needs to be know what needs protection. Establish a deterministic provenance for all of your production artifacts so that you know what you're shipping. Practice defense in depth. You can't bolt on security at the end. Start from the very beginning and then check for the appropriate things along each step of the process. Empower your developers. That's how you achieve velocity. And of course, automation is a powerful tool. Computers are great at doing the same thing over and over again, exactly the same way every time. Humans are less good at that. Automation also gives you that documented auditability of changes that are being made by automation. You can also control access to the automation for confidentiality or other security reasons. Automation is a powerful tool. Use it as much as makes sense. And look for inspiration. This can be really complex. Everybody's application is different, and so look around. See what other people are doing. Look for inspiration or ideas. Learn about things that you don't know yet, so that you can properly take those into account to reduce the possibility of unwelcome surprises later on. So thank you for spending time with me today. I really appreciate it. And I'm going to leave some links up here for you that link back to that Department of Defense DevSecOps reference design in case any of you want to peruse that. But thank you again, and I hope you all have a wonderful day.